Hey, what's up, guys? This is Sean here. Today, let's take a look at this 1,254 number of closed islands. The medium one, this one is not definitely not that hard. I mean, okay, so given like a 2D grid here consists of either zeros represents the land or ones represents water, and an island is like a maximum four directional connected groups of zeros. And a closed island is an island totally surrounded by ones. So it means that an island is a closed island if and only if there are like basically the whole island is surrounded. The whole island is surrounded by ones here. Okay, right. For example, this one here, we have two closed islands. The first one is this one. Okay, this is the first island. Okay, and the second island is this one. Okay, and actually there's a like there's two other like non-closed islands here, right? See, I mean, I think all of you knows there's like this number of islands problem, right? So basically, we just do a like DFS, right? DFS search to find all of the islands. But this problem is a little bit different, right? The only difference here is that we need to find out the closed islands, which does not which are surrounded by all ones. Okay, so yeah, I think that's the only thing we need to add here in our code here. So I'm pretty sure there are like other ways of doing it, but for me, I'm just using like a flag during the DFS search. Basically, as long as I have like every time when we have like the part of the island, I check if that island is on the edge. On the edge means if the if the I is equal to 0 or n minus 1 or the j equals to 0 or n minus 1. Okay, as long as that's the case, okay, then it means that this island could cannot be a closed island because anything on the edge like 0 here, there's no way we can that can be surrounded by ones. So I just ignore that island. Yep. I think that's it. Let me try to code these things real quick. So answer 0, for the DFS, we can either use like a recursion call or we can use a queue, right? So for me, I'm going to use a queue here since queue is a little bit faster than the recursion calls, So m is the length of the grid and the n is the length of the grid 0. Okay, sorry, it's length here. And then, of course, the four directions, okay? And this one, yeah, I don't know. I don't care which direction is this, but all I know is that I need to define all four of them, okay? 0, 1, okay? And then, for this like DFS search, we need to keep track of the visited islands here, right? But in this case, we can just utilize the original grid here. So every time when we see a land here after visiting that cell, we can just set it back to 0, which is water, so that we won't visit the land multiple times. Okay, so basically, if the I in range M here and for J in range N here, okay, if the grid I and J is equal to 0, it means it's a land, right? And then so here we're gonna add these things to the queue, right? I and J. And then I just set these things to 1. Okay. Now this is my flag here. Okay, it's closed. So at at default, I set it to true. Basically, at the beginning, I'm assuming this island we are looking at is a closed one, and now the rest is just like the regular BFS search, or in this case, it's like a queue. Okay, current I, current J, in the queue dot pop. Okay, and yeah, like I said, if the current I is in the 0 or n minus 1, okay, or the current J is in what, 0 or the n minus 1, okay, as long as the current island has any part that's is on the edge of the 2D grid here, then we know, okay, this island cannot be a closed island. So I just set this flag to false. But we still want to continue traversing this whole island because we want to traverse everything to mark everything to be one. Okay, we still want to finish that in directions. Okay, so the new I equals the I plus D0. Okay, and the new J equals to J plus DP. Sorry. DP, maybe I have done too many DP problems. Every time when I define sees a D, I'm assuming it's a DP. Okay, that's funny. Okay, then if the 0, we just check the boundaries here. Okay, new I and M, and same thing for the new J's here. Okay, new J, N. Okay, and of course we also need to check if the new I and new J is a length. Okay, right? Don't forget this part. Then we add this Q. We add this new I and J to the queue here. And then after that, same thing, we're gonna set these things. Sorry, this is new I and new J to 1. Okay, or we can just use like define like a separate visited set every time we just add it to the set. But since we can use the same grid here, we can save that. And then in the end here, we only increase the answers when this flag is true. Okay, right. So in the end, just return. Okay. So I think that should work. It's closed. Wow. Oh, sorry, here. Oh, okay. Yeah. Okay. It should be inside this if here. Okay. A tuple. Okay. 5. That's weird. Hmm. Pop. Okay. Hmm. Yeah, this one shouldn't be that hard. So, but why I'm getting a different answer here? Append this I and J. Okay, that's right. Is close equals to true while Q is here. We pop and we check this one. We set it to false. And then we do directions here. Okay, I and oh, sorry. Yeah, current I and current J. Yeah, this is the issue here. All right, cool. Submit. Ah, some when you are like when you're talking while you're trying to write, type, you're talking and typing at the same times, anything can happen. Please. All right, cool. Cool. So I mean, this thing. I mean, it's pretty straightforward problem. I mean, the only difference here is that you have to check. You have to make sure if this island is closed or not. So the way I'm doing it is like by checking if any of the part of the island is on the edge of the 2D grid. Okay. And yeah, and space and time complexity. So the time complexity, of course, is like m times n, right? Because we have a for loop here, right? But even though we have a queue here, but doesn't really matter because each of the cell will only be in the queue one time. So here you can think it's like an n here, like a O1 here. So I mean, so in total, the time complexity is m times n, and space, since we're not, the space is the space is also a o it's also like a m times n. Because we have a queue here, and the worst case scenario is that you know everything has a zero. Okay, everything has a zero, which means we're gonna insert all the elements into this queue here. So the space complexity, the worst case scenario is also m times n. uh cool. I think that's it for this problem. Thank you so much for watching the videos, guys. Stay tuned. See you guys soon. Yeah, bye bye.